In this part of the episode, we're going to talk about what is called equivalent fractions. And equivalent fractions just means that you have two fractions that look different, but they actually represent the same amount or the same physical quantity. Now, to give you an example of fractions that might be equivalent, let's consider 1 over 4 and 2 over 8. Are these equivalent fractions or not? Do these represent the same amount or the same quantity? One of the simplest ways to answer this question is to just draw a picture that represents each fraction. I'm going to have one pizza over here, and I'm going to have another pizza over here. And I'm going to cut pizza number 1 into 4 slices to represent this denominator of 4 in the first fraction. And I'm going to cut pizza number 2 into 8 slices to represent the denominator of fraction number 2. Now, in fraction number 1, my numerator is 1, which means that in this first pizza, I get 1 slice. In fraction number 2, my numerator is 2, which means in this pizza, I get 2 slices. So question is, looking at these pictures, if these pizzas are the same size, have I gotten the same amount of pizza in both of these scenarios here? And the answer is yes. Visibly, we can see that in both situations, I've gotten 1/4 of this pizza. So yes, it's true. 1 over 4 and 2 over 8 are equivalent because they represent the same amount. What about the fractions 1 over 10 and 3 over 10? If you have the fractions 1 over 10 and 3 over 10, are these equivalent? And I think the answer to that question is definitely no. Because if I drew two objects and tried to represent the fractions that I'm given in those objects, then both of the denominators are 10. So in both situations, I would divide my object into 10 pieces. Now, in fraction number 1, my numerator is only 1 unit, so I only get 1 out of those 10 pieces. In fraction number 2, I get 3 of those 10 pieces. So I'm getting a lot more pizza or a lot more candy bar in this situation. This is definitely not the same amount. And so it's really easy to tell if two fractions are equivalent if they have the same denominator. If they have the same denominator, then the only way to have the same amount from each fraction is if the numerators also match. Because if the denominators are the same, then the pieces are going to be the same size in both situations, right? If the denominators are the same, the pieces are the same size. So the question then just becomes, how many pieces do I have? So it becomes very useful for a variety of reasons to be able to change and manipulate fractions so that they have a specific denominator. So let's talk about how to what is called rewrite fractions. And rewriting fractions means that I want the fraction to be equivalent to what I started with. I want it to represent the same quantity that I started with, but maybe I want to change the denominator of the fraction from what it was to something different. Now, when you are rewriting fractions, there are two ways to create new fractions that are equivalent to the fraction that you started with. two ways. One way is you can multiply the numerator and the denominator by the same number. To give you an example of what this would do physically, suppose, for example, that I had the fraction 3 over 4. I'm going to go into this fraction and I'm going to multiply both the numerator and the denominator by exactly the same number. For example, maybe I will go into the fraction and multiply the numerator and the denominator by 2. If I multiply the numerator by 2, then it becomes 6. If I multiply the denominator by 2, it becomes 8. And I think that 3/4 and 6 over 8 are equivalent. I think that they represent exactly the same amount. And to see this, suppose that I drew a picture to represent 3/4. I'm going to take my picture, take my pizza, and I'm going to cut it into 4 pieces to represent this original denominator of 4. And then I am allowed to take 3 of those 4 pieces. 3 out of the 4. 3 of the 4. But now, if I go into this same picture and divide the pizza further, and I cut the whole pizza so that every time there was one piece, it gets split into 2 pieces. If I split this pizza up, now I have split it into 8 pieces, and I can see that I have already shaded in 6 of those new 8 pieces, right? 1, 2, 3, 4, 5, 6. So 3 out of 4 is exactly the same thing as 6 out of 8. These two fractions, which I obtained by multiplying top and bottom by 2, these two fractions are equivalent. They represent the same amount. So this is one way to make a new fraction that is equivalent to what you started with. You can multiply the numerator and denominator by the same number. The second way to make a new fraction that is equivalent to what you started with is, instead of multiplying, you can divide the numerator and the denominator by the same number. If you divide the numerator and denominator by the same number, then the result of that action will be a fraction that's equivalent to what you started with. For example, if I had the fraction 6 out of 10, if I go into this fraction and I divide both the numerator and the denominator by 2, then 6 divided by 2 becomes 3, and 10 divided by 2 becomes 5. So I get a new fraction, 3 out of 5, from this action. Now I claim that 6 over 10 is equivalent to the new fraction 3 over 5. And to prove that to you, let me draw a picture. Let me take, for example, a rectangle and divide it into 10 pieces. 1, 2, 3, 4. So here I have 10. I've attempted to make them equally sized pieces here. And if I have 6 out of those 10 pieces, then I can, for example, take this and this and this and this and this and this, and I will have 6 out of those 10 pieces that I can take. Now this represents the fraction 6 out of 10, 6 out of the 10 pieces in this bar. But if I just take this same picture and I erase this middle cut, I can see automatically by erasing that middle cut, I now have 3 out of the 5 pieces left when I erase that middle cut. 3 out of the 5 pieces are left. So this shows that 6 out of 10 is the same amount as 3 over 5. Dividing by 2, the numerator and the denominator did not change the amount. So these are the two ways to change a fraction's appearance without changing its actual amount. Multiply the numerator and denominator by the same number. Divide the numerator and denominator by the same number. So, if somebody says, for example, I'm thinking about a fraction that is equivalent to 1/5, but it has a denominator of 10 instead, I'm going to take the fraction 1/5. I'm going to try to either multiply or divide the numerator and denominator so that in the end, the result is 10 in the denominator. So the question is, what do I have to do to 5 to make it become 10? What could I do to 5 to make it become 10? Well, if I'm only allowed to use multiplication and division, I think the easiest way would probably be to multiply 5 by 2 to make it become 10. If I multiply 5 by 2, it will become 10. So I have to multiply the numerator by the same number that will make it 2 over 10. So 2 over 10 will be our new fraction, which is equivalent to what I started with. Somebody says rewrite 7 over 8 so that it has a denominator of 24. So I need to take 7 over 8 and I need to rewrite it so that the denominator is 24 in the end. So the question is, what do I have to do to 8 to make 8 turn into 24? Well, if I multiply 8 by 3, multiplying 8 by 3 will turn it into 24. And if I multiply the 8 in the denominator by 3, then I also have to multiply the 7 in the numerator by 3. So 8 times 3, 7 times 3, 7 times 3 is 21. So 21 over 24. Cut the object into 24 pieces and then take 21 of those pieces. This fraction would be the same amount as 7 pieces taken out of 8.